Welcome to Mrs. Graham's Kitchen. Today we're going to be working on graphs and zeros of a polynomial. A polynomial is a function consisting of terms that all have whole number powers. In other words, the exponent on this power is going to be a whole number, so 1, 2, 3, 4, etc. Not negative, not a fraction. And in most general form, a polynomial can be written as this. A sub n just means some coefficient times x to the n plus another coefficient times x to the n minus 1. So if this was x to the fourth, this would be x to the 4 minus 1 or x to the third, so that each one of the powers go in descending order as far as what the value is of the exponent, okay? And we're familiar with that. We've worked with quadrilaterals and polynomials raised to the third power or to the fourth power. Quadratic and linear functions are the simplest of all polynomials. In this lesson, we will explore cubic, that's x to the third, and quartic functions like x to the fourth, those whose highest powers are x to the third and x to the fourth respectively, okay? For each of the following cubic functions, sketch the graph and circle its intercept. Well, we don't know how to do synthetic division yet or long division on a polynomial. So we are going to do this graphically. We're going to rely on a graph. So I am going to bring the graphing calculator over. Put it right there. Okay, I'm going to make sure you can see. And I'm going to put the function in. So the function is y, or f of x, is equal to, and we're going to put x, and we're going to raise it to the third power. And then we're going to subtract 3x squared. Then we're going to take 6x away. And then finally, we're going to add our constant of 8. All right. Now, this is really important to know what that last term is, because that last term, just like in a linear function, is your y-intercept. Because if all of these x's equal 0, then the y itself will equal 8. So we already know that this is going to cross the y-axis at 0, 8. So let's plot a point up there. This is about 10. So I'm going to go just a little bit less and plot a point, and that's going to be 0, 8. So I think I'll put a 10 in there, just as a frame of reference, okay? All right, now, this is going to be a cubic function, and it's positive. And because it's positive, we know it's going to end on top. If it ends on top, then it goes 3 times. 1, 2, 3. So it starts, when x is negative infinity, it starts down in negative infinity. So it's low. And then it comes around 1, 2, 3 directions, 3 direction changes, and then it always ends up on top because x to the third is positive. All right, so now I have to find some roots to this equation. So like I said, because we haven't learned synthetic division yet or factoring with long division on a polynomial, we are just going to take a look and see if we can find some of the zeros of this function. So let's go right to the table. And when we go to the table, we will see that when x is negative 2, y is equal to 0. So one of the roots is going to be at negative 2, 0. So I keep going down, seeing if I can get any more roots. 3 roots are the maximum, but I could have just 1 root or 2 roots. 3 is the max. So luckily, I have another one at 1, 0. So I'm going to keep going. And I notice, oh, there's another one at 4, 0. Now, just to make sure that I plugged it in correctly, I'm going to take a look at the rest of these values. And I see that they're just going up to positive infinity. And that's what I assumed here when x goes to infinity. Okay? So now I'm going to plot these roots. So I know one of them occurs at negative 2. So I have 1, 2, 3, 4, negative 5. So at negative 2, I have an x-intercept, or a root. And then at 1, 0, I have a root. 1, 2, 3, 4, 5. So at 1, 0, I have a root. And at 4, 0, I have a root. And remember, this is just a sketch. So if we're going to draw it and make it look like a cubic that's starting down at negative infinity and ending at positive infinity, it's going to look something like this. And don't forget we found that y-intercept, and that's going to be helpful to us. We don't know exactly how far that goes down, but it's just a sketch. And then we have a sketch of our cubic, okay? So let's take a look at the next one. In the next one, this says 2x to the third minus 8x plus 9. Now, because our a is greater than 1, and it's also positive, but because it's greater than 1, we know that this is going to be a stretch. So it's going to look longer and skinnier. We also know it's positive, so it's going to follow that behavior. It's going to start low and end high, and there's going to be 3 turns going on. All right, so let me graph that. Let me put that in my calculator. Clear. And we'll put in 2x to the third minus 8x plus 9. Oops. Oh, I don't like when that happens, guys. So I'm going to clear this. There, we'll start over. 2x to the third, then make sure you use your cursor button and that'll take it down, okay? Minus, in case you made the same mistake as Mrs. Graham, minus 8x plus 9. Okay, now I'm going to graph it just to see what it's going to look like. Okay, and it does look very similar to the other one. It does look longer and stretchier, but notice in this graph there's only one root. There's only one solution to this cubic because the other part of the cubic doesn't dip down and create 2 more or even 1 more x-intercepts. So we're just going to be looking for 1. All right, so I notice if I'm looking at it that it lies between 2 and 3. So it's not going to be on my table because my table's in increments of 1. So I'm going to use my calculate command in order to figure out what the 0 is. So I'm going to go second, calculate, and I'm going to go down to 0 and press enter. That's what I want you to do right now too. So you might want to pause the video and try this. And then I'm going to take my cursor, and it says left bound, so I'm going to try to find, let's see where I'm at. The lighting isn't so good here. -3, so I'm already past where I need to be. I want to get between, there we go. There's the cursor. Okay, so I want to get on the left, and remember, you're always going to toggle just left to right. So I'm going to click on the left button, and that's going to take me below the x-axis, and I'm going to press enter. And what that will do is it will just set a boundary on the bottom here at -2.5 for the x and -3.8 for the y. So it's just a point below the x-axis. If I press my cursor to the right, it'll give me a point above the x-axis. So I'm going to press enter. And now it's going to ask me to guess. So it will take a guess. And it's coming up that the 0's at approximately -2.4. Okay, so I am going to draw over here. I'm going to go 1, 2, 3, 4, 5, and I'm a little short here, but that's okay. All right, and we're about -2.4. So I'm going to just plot a point right there. This is -1, -2, -3. So I'm right in between somewhere, a little bit closer to the -2. And I also noticed that I can determine what my y-intercept is because these are both x's. So if I set those equal to 0, I know that I'm crossing the y-axis at 9. So I'm going to plot my point at 9. There's 10, so I know it's over here somewhere at 0, 9. That's not necessarily the maximum. I know I drew it as the maximum here. It's not necessarily the maximum. It's just a point that it goes through. And I'll show you what I mean by that because we know that because it's positive, we have to start in negative infinity and we're going to go up. And your maximum could be over here somewhere. and then it could be coming, as long as it cuts through at 0, 9. These are just sketches. They're not exact. And we know that there is no other x-intercept over here. So at some point in time, we have to scoop and go up, okay? And there is our sketch. Notice that the actual graph is a little bit taller and skinnier, but we're just doing a sketch, and all we're looking for is where are the zeros and how does the graph behave. At negative infinity for the x, it's negative infinity for the y. When x goes to a positive infinity, y shoots up to positive infinity, okay? All right, let's take a look at letter C. For letter C, it says, do the same. We're gonna sketch the graph, circle its intercepts. Now, I notice in letter C, I wanna make sure that you guys get a good view of it, that there are some GCFs I can pull out here. So I'm gonna pull out a 2, and I'm also gonna pull out an x. That's gonna leave me with x squared minus 6x, and then plus 9. All right. So luckily, this looks factorable to me. It's going to be -3 and -3. So this is actually a perfect square trinomial. So I am going to try to write this. I think we're going to take this down, guys, over here. Okay, make sure you can see it. So just so that we can save some room for our graph. So I'm going to say that 0 now, because we want to find out what the roots are, is equal to 2x times x squared minus 6x plus 9. Well, when I factor that, I'm going to get 2x, and I'm also going to get x minus 3 and x minus 3. So it's a perfect square trinomial. And then when we set these equal to 0, we get x is equal to 0, x is equal to 3, and x is equal to 3. Now, this is also an interesting case, because when you have a double root, what that means is that the function's going to come down and it's going to bounce off of the x-axis, okay? So let's take a look at, we know that, that this function is going to hit at 0, 0, so I'm going to plot a point there. We know it's a cubic, so it's going to look like this. It's going to start down in the negative infinity area for the y, and then it's going to turn 3 times, and it's going to go up to the positive infinity. But this point right here is going to bounce on the x-axis, and it's going to bounce on the x-axis where you have a double root. So in this case, it's at x is equal to 3. So I will try to separate these 1, 2, 3, 4, 5. So this is at x equals 3. Okay. We also have a root at 0. So it's going to look something like this. And it's also at 2x to the third, which means it's going to be longer and stretchier. And it's also going to be positive. So it's going to start down below. So I'm going to try to draw something that I think it would look like. I don't know what the maximum is, but I do know that this thing is going to bounce at x is equal to 3, meaning that it's touching there, and that is a root, but it's actually considered a double root. It's not crossing through, it bounces. And when it bounces like that, you're going to find that its multiplicity for 3 is 2, because there's 2 factors of x minus 3 that will give you a root equaling 3. Okay? And so that's what that's going to look like. Let's take a look and see if we can graph it so we can see what that's going to look like. So let's clear that. And take a minute with your graphing calculator and put it in. Maybe you need to pause the video and put it in and see what you get as well. And then just come back to mine and see if when compared, they're equal or equivalent. All right, so 2x raised to the third. And then we're going to subtract 12x squared plus 18x. Okay, so let's take a look and see what this thing looks like. So when you graph it, see how it bounces right there? Now this is very narrow. It's narrower than the one that I drew, but you get the basic idea. okay? And it's bouncing right where there's a double root, just like we predicted, okay? Very good. All right, let's take a look at the next one. It says, clearly a cubic may have 1, 2, or 3 real roots and can have 2 turning points, just as with a parabola, there exists a tie between cubic's factors and its x-intercepts. So for example, this is an x to the third, so it has 1, 2, 3. It also has 3 roots. This particular cubic only has 1 root. And in this case, the cubic has 2 roots, but it's a double root on the 3, and that's why it's bouncing, okay? All right, so therefore, let's take a look at the next one. Consider the cubic whose equation is x to the third minus x squared minus 12x. Algebraically determine the zeros of this function. So we are not going to look on our graphing calculator. We're going to just try to factor this thing. So I'm going to write y is equal to x to the third minus x squared minus 12x. I'm going to set it equal to 0 to try to find the roots, and I'm going to factor out an x. It's going to give me x squared minus x minus 12. And then I am going to factor the trinomial, and I'm going to put in x minus 4 and x plus 3. That will multiply together to give me a negative 12 and add together to give me the middle coefficient of negative 1. Okay? So if I set these equal to 0, I set up a t-chart, and this will come out to x is equal to 0. This one is x minus 4 equals 0, so x is equal to 4. Please don't just write a 4 down there because that doesn't mean anything to me. You have to write it as an equation so I know what you're assigning the 4 to, okay? And this is x plus 3 equals 0, so x is equal to negative 3. Even if you skip the second step, that's acceptable as long as you write x equals negative 3, not just a negative 3, okay? All right, so we have some x-intercepts or roots here. And it says sketch the function on the axis below, illustrating your answer to part A. All right, so if I look and I try to find my y-intercept, I'll find that it falls at 0, 0, because if I make all the x's 0, there is no constant here, so y will also equal 0. So I'm going to plot a point right there, okay? And then I know that my roots are at 0, obviously. I just plotted that one at 4. 1, 2, 3, 4. And I have another root at negative 3. 1, 2, 3. Okay, and I also know that this is a positive cubic, and it's just a typical one. There's no fraction in the front to widen it or to flatten it, and there's no number greater than 1 to stretch this thing. So it's going to just look like a typical cubic. And so if I'm just sketching it, I don't know where the maximums or the mins are, but I do know it's going to look something like this, and then it's going to have to come up. It's going to turn 1, 2, 3 times, okay? And that's how you do B. All right, let's see the next page. Okay, in example 3, it says the largest root falls between which 2 consecutive integers? All right, so we have an x to the third minus 9x squared plus 12x plus 22. Again, this is one of those problems where initially I'd look at it and say, oh, maybe I can do factoring by grouping. But I noticed that 1 and 9 don't have the same factors as 12 and 22, so I won't be able to come up with 2 common binomials. So I say, okay, well, maybe I will take a look at the graph on a graphing calculator, at least until tomorrow when we learn how to find factors of a polynomial. So I'm going to put in y equals, and we're going to put in x to the third minus 9x squared. Oops, I did that again. Sorry, guys. Let's try that again. X to the third. There we go. Minus 9x squared. and then plus 12x, and then plus 22. Okay, and I'm going to take a look at my table, and I'm going to say, okay, can I find any of these zeros? First of all, you can take a look, and you'll be able to see between 8 and 9, first of all, both of those are positive. 8 is 54, 130 is, when x is 9, y is 130. So those are both in the positives. So the root can't fall between those. The root has to fall between a positive value and a negative value, because it's going to look something like this. This is either 4 and 5, 6 and 7, 10 and 11, or 8 and 9. And somewhere there's going to be a root falling between them. When that happens, the value at this first integer is going to be in the positives, and when we get to this integer, it's going to be in the negatives. So that's what we have to look for on our table. So I go over to 6 and 7, and there you have it. Between 6 and 7, at 6, y is equal to negative 14. And at 7, y is equal to 8. So in this case, it's just the opposite. If this is 6 and this is 7, we're starting at negative 14, and then by the time you get to 7, you're up at positive 8. So the root is somewhere between 6 and 7. Now you can take a look at some of the others to make sure that you're correct. Between 10 and 11, you see that they're both positive. And between 4 and 5, they're both negative. So the answer has to be between 6 and 7. Number 2. Now it says algebraically determine the intercepts of this function. All right, notice this is an x to the 4th function minus 5x squared. We can take an x to the 4th and we can divide that up just like we do x squared, except instead of having x in the first binomial and an x here like we normally do, because this is x to the 4th, we have to break that down into x squared and x squared. Luckily, our middle term has an x squared in it, so when we add our outer product and our inner product, we'll still have that x squared, so this thing will hold true. Okay, so I have to look for two factors that multiply together to give me 4 and add together to give me negative 5. Because this is negative, I'm going to need two negative factors. So I'm going to pick negative 4 and negative 1. I'm going to erase these lines now too so that you can see. Okay, and this is going to be equal to my function, y. This is equal to y. But now I'm going to set this equal to 0 because I want to see where the zeros are, or the x-intercepts. I recognize that this is a dots problem. Both of these factors are difference of two perfect squares. So I'm going to factor again for both of them. This is going to become x plus 1, x minus 1. And x squared minus 4 is going to become x plus 2, x minus 2. We're going to set that equal to 0. And if I have to find all these roots, I'm going to set up a t-chart for everything. And we're going to get x is always the opposite. I could put x plus 1 equals 0. I can skip that step as long as I write x equals negative 1. Don't just write a negative 1 down there, guys. So this one's going to be the opposite, x equals 1, in order for that factor to equal 0. X is equal to negative 2, and x is equal to positive 2. All right, so I'm going to verify my answer by sketching the graph of the function on the axis below. So I'm going to plot all my x-intercepts. So here's at negative 1, here's at positive 1, here's at negative 2, here is at positive 2. Now I notice that this is a quartic, which means it's an x to the 4th. That means it's going to change direction 4 times. So it's either going to be an m or a w. All right? So because this is positive, I know that I'm going to start, I have to end high. So if I have to end high, I'm going to count 4 times. 1, 2, 3. I'm kind of working backwards, okay? That means that I had to start high. All right? So at some point, I have to do something that looks like this. Well, before I do that, though, let's find out what the y-intercept is. And if you can find it easily, you always want to get that as a point. So When x is 0 here and here, y will equal 4. So I'm going to go up. There's 5, so there's 4. So I know I'm crossing through there at some point. Not exactly sure how, but I will be crossing through there. So my graph's going to look something like this. It's going to cut through and it's going to turn around at some point. Okay, and it doesn't necessarily have to hit a maximum at that point, but it's going to have to turn. Maybe it goes down really low. We don't know. We're just looking at the zeros right now, and we're just looking at the behavior of how the function moves, okay? And so this is what the sketch is going to look like. And notice it does look like a W. And it's positive because the coefficient in front of the x to the fourth, the number in front of the x to the fourth was a positive. And when it comes to even functions, which is what this is, they almost have a mirror image. They have a mirror image as far as direction, but not exactly the points that are being placed on here. Sometimes they're exact, but this is an even degreed function. Not an even function, but a function of even degree. And so that means it starts high and then it ends high, okay? Let's take a look at the last one. Okay, class, we're going to finish up the last problem. Sorry for the interruption. We had someone at our door. So we will start again. So they ask you to consider the quartic, and you put this into your graphing calculator, and I believe I already have mine in. So if you want to take a minute and put x to the fourth plus 3x to the third minus 35x squared minus 39x plus 70 into your graphing calculator, pause the video, and then when you're done, you can turn it back on. Okay? All right, so I do know that when all of these x's are equal to 0, my y value is going to be 70. That's my y-intercept. So if that's 500, I'm going to mark off by hundreds. And so if this is 100, then 70 is going to lie somewhere around there. So I am going to have a point on my graph at 0, 70. Then I'm going to take a look at the table to come up with all the different values that I can find. So I'm going to go second table. And I look and I find my first 0 is at -7, 0. So there's 5, -5. So I'm going to go 6, 7, 8, 9, 10. And so I'm going to plot a point at -7, 0. And then there's another one at -2. 1, 2, 3, 4, 5. So at -2, 0, there is a 0 or a x-intercept. And then I also find one at 1, 0. Let's see, there's 5, so it would be 1, 2, 3, 4, 5. So there's 1, 0. And I think there's a last one in here somewhere. There we go, at 5, 0. Okay. This is a quartic, so it's x to the fourth. It's a positive coefficient in front of that x to the fourth. So that means we're going to get a W, not an M. And so because it starts out happy, and it ends happy. This is just a sketch. Don't exactly know where these points are, but we do know where our intercepts are. Now it asks us to label the intercepts. So they're at -7, 0, -2, 0. Don't put the y-intercept because we're just looking for the x-intercepts. So we have 1, 0, and we have, I'm going to erase that a little bit so we can see it. And you have 5, 0. So we have 4 roots. We didn't have to have 4, but we can have only a maximum of 4 roots, okay? So now you guys will be working in class on the fluency work, and you can use this as your guide. All right, have a nice day. Bye-bye.